our next instruction that we would like to document is instruction increment EDI, and this is the encoding of this instruction. And look how there is a single byte, and therefore this is the predictably just a single byte code here. Let's take a look at the documentation. Let's jump back to the index, and this is increment instruction. So again, alphabetically we locate this, and so it's using 40 plus RD or 40 plus RW, but remember RW is 16-bit register, this RW thing right here. So if this was a 16-bit instruction, there would be 66 hexadecimal prefix in front of it, but we don't have a prefix. So therefore, clearly this is our case right here. This is what the instruction is using. Copy and paste. Okay, so 40 plus RD increment like this. So the description is increment double word, okay, a register by 1. So what's left is to find out what the register is. So therefore, so in our case, what we have is that opcode is 47. Which equals 40 plus RD, right? 40 plus RD. Therefore, RD equals 47 minus 40, which equals 7. Okay, and this is our register code. Right, so if you look it up right here, once again, plus RD right here indicates register code, so you can copy and paste to this part. So what is this register? Register code, again, we just jump to the reg field documentation, 7, right? This register code that we have is 7, which is 111, a binary, and in this documentation, of course, it's once again register EDI that we use in this instruction. So this register code 7 indicates register EDI, something like this. Mode RM byte, no. It's not just one opcode, nothing else, just 1 byte. So there is nothing like this. And presence of any additional bytes, none, right? So we don't have any, none. Okay, so let's proceed to the next increment instruction, increment AL. Back to our coding, and increment AL appears to be like this. Okay, so this is our instruction. So FEC0, let's take a look at increment FE. Okay, so FE is the actual opcode. FE is the actual opcode, followed by /0. So opcode is FE /0, so which means that increment I'm trying to copy it from here, increment register or memory by 1, right? So this is the explanation, and 0, right, forward 0 means that back to the documentation, digit indicates that mode RM byte of the instruction uses only the RM register or memory operand, and the reg field contains the digit that provides an extension to instruction opcode. So let's drop this. So let's copy this documentation into our own handout. Now let's increase the size of this. So 0 is a digit between 0 and 7, indicating mode RM byte of the instruction. Uses only RM register or memory operand. Okay, so register or memory operand. Let's so in our case it's C0. Okay, so we need to take C0 right here. Let's fix the spelling. Provides an extension. Okay, and so C0. So this /0 equals C0, and which equals a binary version of C0 will be, if we enter, let's switch to byte and say C0. Okay, so this is binary 11000. All right, so it's like this. So I guess we can try to Control C and Control V. No, it didn't work, so I'll just use 1100 and then 0000, and let's split the fields according to mode RM byte format, right, which is this format, and that's what we just did. And of course we're using only RM part of it, but RM part of it, which is the last 3 bits, is always used with the mode bit. So here let's just use this mode RM equal 11, which is this, and 00, which is this. 00, and this indicates or means, the meaning of this encoding is here in mode RM byte explanation, and our case is 11000, which is here, and this is register AL, AX, or EAX, right? So we can keep copying, means AL, AX, or EX, but in our case we know that our choice is a byte increment, byte by 1. So this is the byte. This is 16-bit and this is 32-bit. So means register AL, right? So we can just get rid of the rest of this, and that's our answer to this challenge. Mode RM byte present. So here, yeah, it is, yes. And explain briefly how mode RM fields are used. We explained it here. So let's just copy these two. We can duplicate it here. I think that's good enough. And explain the presence of any additional bytes. There is none. Okay, so none of these. There is none of these. Okay, so this is our work on 2 of these increment instruction formats.